when I say rational expressions, tell me what I mean. What's rational mean?
Not fraction.
Okay, keep going. You're close. Flip that around. That's irrational. Is not fraction. So if it's not a fraction, then if not a fraction is the opposite, then what is it? It is a fraction, right? That's what, I don't know why I can't spit my words out. I don't know. I just confused you. Okay, think rational fraction. Okay. Oh. Okay. No. Let's think about that is quite all right. Something like this. This is a rational expression. Now they're going to get way more complex than this. But for the sake of example right now, we're going to start easy. So if I have this, do you agree that everything's being multiplied here? How would you simplify this?
You can simplify the x.
I see people doing this. Yes. The x's cancel out. You can slash them out, right? Because as long as I'm multiplying, they cancel. Now understand, if this was 2 plus x over 5 plus x plus y, they do not cancel, right? It's only when you're multiplying that they cancel. Okay. The reason, no, not when you're subtracting. Only multiply. You can't add them like that. Yeah. Here the reason is, somebody asked what's the reason. Well, because when you multiply, so this is the same thing as 2/5 times x over x times 1 over y, right? X over x is 1, and you can multiply 1 by anything, it stays the same. So then I still have, come on, 2/5 times 1 over y, which is 2 over 5y. That's why it cancels. Anything over itself is 1. Okay, and you can multiply it. You don't have to put the 1, it's implied. Because it's not the same, you can't just split this up. If I were to split this up, I'd have to do 2 plus x over, I'd have to do 2 over 5 plus x plus y plus x over 5 plus x plus y.
That is nuts.
So no, you couldn't simplify this any further. This one only when you're multiplying. And you'll see why I'm stressing this so much, because we're going to put some addition and subtraction in here, and you'll have to simplify. That would be all you do. Yeah, that'd be all you do. All right, so the key to this is going to be, guess what the key to this section is going to be?
Factoring.
Yes. How'd you know? Because that's the key to everything, is factoring. So let's say, actually, yeah, I think I'll do an example and I'll make some notes off to the side. Let's say I have x squared minus 2x minus 15 over x squared minus 9, and I'm asked to simplify. I don't want to know what I just want to simplify the fraction itself. Okay? So what I want to do when I simplify is, first off, what do you think?
You mind, like, or find the GCF.
Factor the top one.
Okay, but if you find the GCF, that's the first step in what you're doing, which is factoring. That's exactly right. When you simplify, you want to factor top and bottom, factor everything completely.
X plus 3, x minus 3.
On the bottom, that's right. It's a difference of 2 squares.
-3, or no, -5 times 3.
Yes. This is an easy factor because the leading coefficient is 1. Anybody confused?
That means
Oh,
that
wait,
we're
no,
gonna have
the 2x.
Yes, all the factoring stuff's going to come up. Even sum and difference of cubes. All of that will come back up. Now, notice what you have. And here's what I'm going to tell you to remember. Before you start marking things out, make sure every plus or minus that you see is enclosed in a parenthesis. Okay? So if there was a plus here, I couldn't start marking out yet. But every plus or minus is in the middle of sets of parentheses, right? So that means it's this times this and this times this, right? So now, once I've got nothing but multiplication across the top and across the bottom, then I can cancel out factors. In other words, I see x plus 3 and x plus 3. Cancel that out. It leaves me with, Can I mark those x's out? No, they're being added or subtracting. They're plus something, they're not multiplied. So this is as simple as you can get.
Just simplify.
We're multiplying, dividing, and simplifying. You're going to simplify everything you do, so I had to show you simplify first, but we're going to multiply and divide today. Yay! Y'all want to try one more simplify? Let's try one more simplify. You try this one. I'm going to pause the video and give you a chance to try. Back in, if you're still working, continue. Some of you are talking about problems, some of you are talking about other stuff. So let me read you back in. Thank you. All right, up top, GCF is what? What's left when you take that out? On the bottom, some of you said you couldn't remember how to factor, so let's refresh. A times C is 15. What multiplies to 15 but adds to 16? 15 and 1, so I have 3x squared plus 15x plus 1x plus 5. GCF for the first two?
Yes.
What's left? GCF for the second two? 5. So it factors as x plus 5 times 3x plus 1. Can you cancel anything out? Yay. Pretty easy, right? It's the blue circle look there. What? All right, simplified, yes? That's Roman numeral 1, right? Huh. We're going to multiply rational expressions, yeah. If we think about rational expressions as fractions, which they are, it makes it a whole lot easier as we go to multiply. When you multiply fractions, tell me what you do. Straight across, right? Like if I have 2/3 times 5/7, then it's just top times top and bottom times bottom, right? We're going to apply that same concept when we multiply rational expressions, okay? But the key to this is we're going to simplify first, simplify each fraction first if we can. Then multiply, and then simplify again. Multiply, but we're not going to actually multiply out because once we've got it in completely factored form, to FOIL it out and multiply it out, we'd be going backwards, okay? So this is really not difficult. So multiply and then cancel out what we can. For example. What did you think it said? Multi-day. Multi-day. All right, so for example, there's one rational expression. I'm going to multiply it with another rational expression. Let's do x squared plus x minus 20 over 3x. Okay. Well, but if you look at it and you just simplify each one first before you start, okay? And by simplify, remember that means factor out completely and cancel anything that can. No, it really doesn't. Like, now add, subtract, yeah, that'll take a little while longer, but no, we're just multiplying divide today.
Want those three x's cancel?
Not as they are, because look, in order to make sure that each addition and subtraction is enclosed in parentheses, you'd have to do this. Are you talking about after you factor they cancel, or are you talking? Yeah, after they factor. But as they sit now, no. First we have to factor each one. I didn't mean to do orange. Okay. All right, so up top, I'm going to take out what first? Leaves me with
1 and x.
on the bottom, can it factor?
Yes.
Yes, how does it factor?
X minus 4.
Remember, it's got to multiply to -5, but add to +4. How about the second fraction? I'm looking up top first. Does it factor? -4. Oh, wait. That's right. Is it what? Say that again. Okay, it's got, do you see where though? It's got to multiply to -20 and add to +1. So +5 and -4. Now, here's what I do because I work smarter, not harder. Everything's multiplied. I don't rewrite it. I just do that. Right? Because that implies multiplication. Top times top and bottom times bottom. That's fine. Yep. Okay. As long as every plus or minus is enclosed in a parenthesis, and it is. Well, now let's simplify. Let's cancel out. What all cancel? Several of you have said the 3x. That's the first thing you see. Ah, this is an x minus 1. X plus 5. Now.
One of them is 1 minus x.
Now I could easily manipulate that to make it x minus 1. Right now, right now it's -x plus 1, right? I just moved them around so you could see with the x first in standard form. X minus 4 over x minus 1. What could I factor out of that first parenthesis? A -1. So yeah, you do want to do that if they're that close. If they're off just by a sign, so leave me with x minus 1. Because that way, that whole piece cancels. That's right, and it leaves you with -x plus 4. That's the answer. Yeah. If they're only off by a sign. Oh, it's hot in here. One more example. In fact, let me, guys. I know y'all are excited about rational expressions and whatnot. I want you to try this one on your own, and then we'll come back together and work it out. Because I got one more type of multiplication I need to show you before I show you division. I will.
Sounds so professional.
So up top, I won't do that, even though I am lazy enough to do it. I'm going to take a 5x out. It leaves me with 4 minus x. On the bottom, I'm going to take an x out. It leaves me with x minus 1. Over here, I have x plus 4, x minus 1. And this is the difference of two squares, so I got x minus 4, x plus 4. And I'm going to just start marking stuff out. X plus 4's go. Come on. X minus 1. This is real, yeah, the x's. This is really close. Again, it's the signs that are wrong, right? So if I make this -5 and this a negative and this a positive, now they'll cancel. How many of you in here got -5?
Alrighty, I took -5.
Yay, pat yourself on the back if you did.
I stopped right
Wait, Miss McGee, so all you do is flip the sign on it and it'll get the same?
Yeah, because this one's positive x, -4. This one was negative x, positive 4. So if you flip the signs, if you ever encounter any ones that all you have to do is flip the signs, take a negative out of it and put it on the outside. Yep. All right, a couple of them might look a little bit different. Let me show you what I'm talking about. This is really a review from chapter 2 with properties of exponents, but if I don't show you, I didn't always show it because I assumed you would know. But then I would have students come in and say, we didn't know how to do this, and I thought they were the easiest, so let me show you. In fact, I remember doing something like this because I vaguely remember telling y'all to just make it one big fraction, but maybe not. If I'm multiplying here, remember that's straight across, right? There are no plus or minuses. I'm sorry, I'll give you a second. Ever teach y'all? Let me get this on the recording. Did anyone ever teach y'all the way to simplify fractions the way they sit here? Like 5 and 15 simplified to 1/3. Well, no, you're not really cross multiplying because you only cross multiply when there's an equal sign in the middle. But you're just looking at top and bottom. Before, like, instead of doing 5 times 27 and 3 times 15 and getting huge numbers, the way they sit now, I can start simplifying top and bottom. No, you don't have to do it across. This is one big fraction. So it could be written like this. It could be written as 5 times 27 over 3 times 15. And I could still do 5 and 3. You see what I'm saying? Mm-hmm. I don't know, simplifying fractions.
Oh, I've got strict control.
Yes, you can do the 9. So 27 over 3 is 9 up top. And now the 9 and the 3, 9 divided by 3 is 3. That was a lot easier in my opinion. Right. Exactly. When you're multiplying across, you add the exponents, right? So x squared and x to the 5th is what? Uh-huh.
This like made sense while I'm doing it.
I'm gonna get home.
Just go across it. Look, this is not, I'm not saying you have to simplify the numbers in front the way I did. If it makes more sense to you to take out your calculator and do this. Oh, you stupid, stupid calculator. If you did 5 times 27, and then you did 3 times 15, and then you did 135 was on the top, 45 was on the bottom, and you got 3, that's fine also. Whatever, I like to do whatever I can without a calculator, but I mean, that's just me. Is this one simplified?
No.
Why? 7 minus 5 is... And if I have 3 on top and 5 on bottom, it leaves me... You flip it so it ends up... And if you can do that in one step instead of 2 at this point, that is perfectly fine. Like if you see there's more in the bottom than there is in the top, then the remainder is going to stay in the bottom. That's fine. Subtract them. All right, let me show you division. Tell me this. When you, and this is going to be so stupid easy when you see it, but you're going to go, what? When you divide fractions, let's take this. What did I use first? 2/3 and 5/7?
Oh, so it's just multiplying. You just have to flip it.
That's exactly right. We multiply, so it's multiply all over again by reciprocal.
So then it should.
I love it. All right, so let me do one example with this and I shall be done.
Wait, so all we do is just take the same type of thing.
Flip it and then do the same thing we just did. I'm going there's one I wanna show you that we haven't really talked, like, one with a different pattern in it, just to make sure you remember how to factor it. All right, let me show you an example. All right, 3x squared plus 5x. Do it. All right, if you're still working, don't look up, don't look up, don't look up. I'm not gonna talk, I'm just gonna work.
You don't start.
What?
Don't start. No, start. Don't look up.
I'm not allowed to be
Yeah, so then that's
screwed. Like, I can't just.
Oh, that's 15, not 5.
I don't think I am.
My apologies. Ooh, yuck. What's 6 times 15?
90.
Are we allowed to just do square root for x?
Yeah, am I allowed to square root it?
Make that just 2x.
It has to be.
You do 2x times 2x if you need to get rid of a 2x for some reason.
Do I? No, I don't think that would work.
Now this is better. It's raining, it's pouring.